Welcome back to Dapra's milling training video series, where we introduce important concepts for milling that will help you achieve the best performance from your cutting tools. Now, your cutting tool manufacturer's catalog should provide recommended speeds and feeds for your cutting tool, but these will generally be provided in surface feet per minute and feet per tooth. For your CNC program, you'll need to convert these numbers into revolutions per minute and inches per minute. This video will first show you the math for doing this manually, then introduce you to Dapra's online tool for doing the calculation digitally. This example of a speed and feed chart shows the recommended surface feet per minute and feet per tooth ranges for a particular insert in tool steel material. So how do we translate these numbers into usable revolutions per minute and inches per minute numbers for our CNC program? Here are the most important and commonly used formulas for calculating speeds and feeds. Once you have your speed in surface feet per minute and your feed in inches per tooth from the catalog recommendations, you're ready to plug those numbers into these formulas to calculate your program speeds and feeds. For our machining program, we need to know what RPM, or revolutions per minute, and IPM, inches per minute, that we want to input. To come up with the RPM, we'll need to take the SFM pulled from the catalog, multiply it times 3.82, and then divide the result by the tool diameter. To arrive at the inches per minute that we'll input into our program, we'll need to multiply the RPM times the feet per tooth that we got from the catalog, then multiply again times the number of teeth in our cutting tool. Now those are the two biggies, helping us arrive at programmed speed and feed. Also shown are formulas for arriving at the SFM and feed per tooth that an existing program is set to. Now this is very helpful in determining if an older program is suitable for newer tools or if the program needs editing. Finally, we have a formula for calculating the total material removal rate, or MRR, of a machining program. This is a valuable formula that helps compare various methods of cutting, allowing you to choose the most effective approach. Cycle time calculations are dependent on this formula, so this one helps tell you how much time a cut should take. Let's work through a few examples to help make all of this come together. So, our first example, let's look at the speed for a 2-inch diameter 5-flute shell mill. We've pulled 800 surface feet per minute from the catalog, as well as an 8,000 feet per tooth. So to get RPM, we multiply surface feet per minute times 3.82, then divide by the tool diameter. So for this example, 800 SFM times 3.82 divided by 2 gives us 1,530 RPM. So for that same example, how do we come up with our feed rate? Well, we had a 2-inch diameter 5-flute shell mill, 800 surface feet, and an 8,000 feet per tooth. Our feed in inches per minute is found by multiplying the RPM times the feet per tooth times the number of teeth. In this case, 1,530 RPM times 8,000 feet per tooth times 5 teeth gives us 61 inches per minute. The metal removal rate for that example, in other words, the volume of material removed per minute. We had 1,530 RPM at 61 inches per minute. Let's assume the depth of cut is 100 thousandths and we have a 1-inch width of cut. So the metal removal rate is depth of cut times width of cut times inches per minute. In this case, that's 61 inches per minute times 100 thousandths depth of cut times 1-inch width of cut comes out to 6.1 cubic inches per minute. Let's look at a second example. How do we get our speed for a 1-inch diameter 3-flute end mill? Our catalog numbers are 450 surface feet per minute and a 5,000 feet per tooth. So again, to get our RPM, we're going to multiply surface feet per minute times 3.82 and divide by the tool diameter. 450 surface feet times 3.82 divided by 1 gives us 1,720 RPM. So how about the feed rate for that second example? We have a 1-inch diameter 3-flute end mill, programmed at 450 surface feet and 5,000 feet per tooth. Our feed in inches per minute is equal to the RPM times the feed per tooth times the number of teeth. So for this example, 1,720 RPM times a 5,000 feet per tooth times 3 teeth gives us 26 inches per minute. So the material removal rate for that previous example, we had 1720 RPM at 26 inches per minute. We'll assume 150 thousandths depth of cut and a 600 thousandths width of cut. Metal removal rate is equal to depth of cut times width of cut times inches per minute. In this case, we have 26 inches per minute times 150 thou depth of cut times 600 thousandths width of cut gives us 2.3 cubic inches per minute of material removal. So how about going backwards? Let's calculate speed from an existing program that's running a 3-flute 1.5" end mill at 1650 RPM and 30 inches per minute. What is the surface footage and feed per tooth? Well, surface footage is equal to the RPM in the program times the tool diameter divided by 3.82. So in this case, 1650 RPM times 1.5 diameter divided by 3.82 gives us 650 surface feet per minute. That is the speed that this program is running that particular cutter at. Now going backwards on feed rate, that same program is running that 3-flute 1.5" end mill at 1650 RPM and 30 inches per minute. What's the feed per tooth? Well, feed per tooth, or IPT, is equal to inches per minute divided by the RPM divided by the number of teeth. Now if we just take the 30 inches per minute and divide by the 1650 RPM, we get the inches per rev, which in this case is 18 thousandths feet per rev. But we divide that feet per rev by 3 teeth, and that gives us 6 thousandths feet per tooth. Now all of our calculations have been done manually to illustrate the process of arriving at proven numbers based on your cutting tool manufacturer's recommendations for their product. Now a faster and easier way to get your program speeds and feeds is to use Dapra's website speed and feed calculator. Set up like an app, Dapra's website allows you to simply plug in the cutting tool information and the catalog recommendations for surface feet per minute and feet per tooth, along with your intended depth of cut and width of cut. The calculator does the rest, providing the speed in RPM and the feed in inches per minute and the material removal rate for the parameters entered. This handy online tool makes quick work of the speed and feed calculations and minimizes mistakes. Load a shortcut to this website on your smartphone's homepage and you'll be one click away from accurate speeds and feeds for your milling tools. Visit www.dapra.com and select the Resources tab to find the correct calculator for your cutting tool type.